Shalom to you and welcome. In this video, we'll solve or evaluate right triangles, trigonometric functions of acute angles in a right triangle. So there are 6 of the trigonometric ratios in a right triangle. So you have the ratios of the two sides out of 3. So you have to get the right one. The side opposite the acute angle, as they are directly opposite it, draw a line to face it. The side adjacent to it, so it's going to have, that side is going to come from the vertex of that, connect to the vertex of the angle. And then the hypotenuse is always facing the right angle. So take that apart. So it depends on where the angle is. Excuse me. So the 6 strict ratios are sine, cosine, tangent, cotangent, secant, cosecant. And these, the sine, SOHCAHTOA, you already know from geometry. So sine, opposite of hypotenuse. Ka, cosine, adjacent of hypotenuse. Toa, tan, opposite over adjacent. So the cosecant is the inverse of sine. It is the inverse. So you just, or reciprocal, just flip it. You see, cosecant will be opposite, hypotenuse over opposite. Okay. Then secant is the reciprocal of cosine. So you flip it, hypotenuse over adjacent, and cotangent is the reciprocal of tan. Adjacent over opposite instead of opposite. So once you get the first 3 basic, the other 3 you just flip them to get their reciprocal. So how I remember it, if you see sine starts with S, cosine starts with C. So they are kind of alternative. Sine S, cosecant is the reciprocal starts with C. Cosine is the angle, the reciprocal of cosine starts with S. Okay, so then tan is cotan. Now let's solve a problem. So here we are given 2 sides. We look at the right angle. The right angle is opposite 17. So 17 must be the hypotenuse. So once you identify your hypotenuse, we are given this side of the leg. So we don't know the side opposite because this side is adjacent to, it's connected to the angle, the vertex of the angle. So it's the adjacent side. We don't know the missing side, so let's find it first because we need all 3 sides to write our 6 trig ratios. So we'll use Pythagorean theorem, which is hypotenuse squared is equal to leg 1 squared plus leg 2 squared. So let's just label it b squared. So 17 times 17 is 289. And 8 times 8 is 64 plus b squared. So now we subtract 64 from both sides. We should get 662 equals b squared. Now we take the square root of, that's 665. Okay, take the square root of 225 to get b, and it's a perfect square, so it's 15. So now that we know this side is 15, then we can go ahead and write our trig ratios. So sine theta is opposite, which is 15, over hypotenuse, which is 17. Cosecant theta is, you flip it, 17 over 15. And cosine theta is adjacent over hypotenuse, so it's 8 over 17. And secant theta is 17 over 8. Again, you flip the reciprocal of cosine. And then tangent, tan theta is opposite over adjacent. So that's 15 over 8. And cotangent, this is cotangent theta is 8 over 15. And that's it. That's the 6 trig functions. Okay. Let's try another one. Okay, here we're given, it says that C is the right angle of this problem. So if we draw a right triangle, because where the right angle is, we call it C. And then we can decide where we want to put our A and B. It wouldn't matter. But this, if the A is the opposite angle A, side A is opposite angle A. So if this is A, here must be 15 then. And if that is C, it has to be opposite the angle, side opposite angle C. So this will be the hypotenuse. Again, we're going to use Pythagorean theorem to find C, to find B, that side there. So C is the hypotenuse. So it's going to be 16 squared is equal to 15 squared plus B squared. So 16 squared is 256 equals 225 plus B squared. Now subtract 225 from both sides. We're going to get 31 equals B squared. Take the square root of 31 to get. So when you're asked to solve a triangle, it means find all the missing sides and all the missing angles. So we're going to find angle A and angle B because we know already the angle 90. So angle A, so we can use anything, sine, cosine, tangent, which any side, but we have to make sure we use the right proportion. So sine of angle A is opposite over hypotenuse. So sine of angle A equals opposite over hypotenuse. And then to find angle A, we are going to take the inverse sine of 15 over. So angle A is going to be the inverse sine. Plug it into your calculator. That was second function of sine, and you do 15 over 16. Make sure your calculator is in degree mode. The angle is in degree. So it's going to be about 69. They ask us to round to the nearest tenth. So it's 69.635 and so forth. So we're going to round to nearest tenth is approximately 69.6. And then we do the same thing for angle B. So what do we want to use? We can use which one connects these two. So angle B is going to be adjacent over hypotenuse. So you're going to do cosine adjacent over hypotenuse. So we use cosine B is going to be adjacent 15 over 16 also, but it's cosine now. So B is going to be the inverse of cosine 15 over 16. So second function of cosine, and then 15 over 16 would give us approximately 20.4 if we round to the nearest tenth. And that will be it. So we have found all the missing side of that angle. Alright, let's do a word problem. We are told that this loading dock ramp requires a rise of 1 foot and 3 feet horizontal length. So, and when we asked to find B and C and then find the measure of angle theta. Well, if you see here, we have only one side we know. There's no way we can find B and C, but they gave us this information. So, which will be another right triangle here with a rise of 1 and a horizontal of 3. So, and so these two triangles will be similar. So we use proportion to find that vertical over horizontal equals vertical over horizontal. So over B. So we cross multiply. B times 1 is B, and 4 times 3 is 12. So that's B. So now we know that this side is B, and then we can use Pythagorean theorem to find C. The two legs connected to a right angle. So hypotenuse is opposite. So C squared is equal to 4 squared plus 12 squared. So C squared is 16 plus 144. We add those, we get what? That's 160, I believe. And then, so C is the square root of 160. And then 16 times 10 would give 160. So the square root of 16 times 10. And 16 is a perfect square. Square root of 16 is 4. So 4 square root of 10. So here we have C is 4 square root of 10. That's that side. And then what else are we asked to find? That's B and C. So we have found B and C. Now we have to find the measure of angle theta. So angle theta, we decide which of the SOHCAHTOA we want to use. Well, I think it's easier to use 4 and 12. So let's see. Angle side 12 is adjacent to angle theta, so it's connected to it. So adjacent, and the 4 is opposite of it. So adjacent and opposite is TOA. Okay. Opposite and adjacent. So let's make sure the order opposite comes first. It's on top there. So tan theta is opposite, which is 4, over adjacent, which is 12. So to find angle theta, we are going to take the inverse of tan. So that will be 4 over 12. And plug it into your calculator. Again, it's second function for tan. Second tan is 4 over 12. And it's like 18.4349 and so forth. So let's round again to the nearest tenth. And that will be that.